Now, the things that we discussed in the previous hour, each one of them, each one of the requirements in that project selection is actually trying to teach you how you should handle a certain type of realistic scenario, requirement. If thens, either ors, all right, they're already in the statement. But some of them, x1 plus x2 equals to 2 kind of thing, you will utilize those kinds of tricks a lot. Okay, now let's come back to normal problem type of things and utilize those binaries when we need them, yeah? Modeling fixed cost. We did formulate the version where we have power plants and factories and we were sending electricity between them with minimum total cost, yeah? But there was no cost for leasing or buying or whatever. The only cost we discussed back then was per unit transportation cost, and we were multiplying with the amount. How about we have a different scenario? You have your customers, and you have a potential set of warehouses. You can buy the warehouse, lease the warehouse, whatever, all right? You don't know which one you're gonna use. It was the case like in the power plant, all of them was there, already available, and we were just taking the electricity from them. What if you pay a fixed amount if you make an agreement with that power plant, okay? That is like modeling fixed cost. So there is a fixed cost, you pay it if you lease the land, if you buy the land, if you make an agreement, if you decide to use that particular power plant. That doesn't depend on how much you're taking, all right? If you take 1 watt or 1,000 watts, it's the same fixed cost. Right? Those are called fixed costs, and the other versions are variable costs because they depend on the amount, yeah? You multiply it with the amount you're carrying because those are per unit transportation cost. So what's gonna happen if you have, all right, we have a potential warehouses that we can lease, and we have our clients, customers. If we decide to use the warehouse, we're gonna pay a fee. If we decide to use the warehouse, there is a fixed cost, okay? There is also cost of transportation from I to J, all right? If we lease the thingy there, then we're gonna send it from there, yeah. But my decision then should also include the fixed cost that I'm gonna pay to the warehouses. So the problem is then, I again have my capacities, the supply amount that warehouse can ship, and my demand, all right? So I have my customers. Those customers require electricity. I'm trying to refer to the problem that we already did, all right? They require electricity. There are 3 potential power plants that I could get electricity from, yeah? But each power plant, all right, there is this transmission cost, the wire thingy, plus once you make an agreement, you need to pay for it, a fixed cost. How can we handle this? I want you to define the decision variables first. What are my decision variables? How about you define the amount first? What was it? Aha. Come on. I have demand, I have supply. I want to satisfy my demand from this supply. What is the thing that you're trying to decide? What is your decision variable? Yes?
Amount sent from warehouse to customer.
Yes, so how would you say that? Let Xij, can you see this? Yes. Amount of goods, whatever it is, right? Amounts of goods sent from warehouse I to customer J. You see how I define my variables, by the way? Amount sent from I to J. You also have to tell me where is I from and where is J from, but we don't know the, oh, I is from 1 to M, and J is from 1 to N. You also tell me where the indices are coming from, yeah? Okay, this is for the amount I'm sending. All right. Let's try to model this. Do you need another variable? What is it? What is the other? Well, when I say do you need another variable, some of you nodded. Some of you are still not with me, but whatever. We'll go with the ones who can follow. Do you need another variable? Yes, what is the other variable? The amount of what? Do we need that? Rest of the class. Your friend is suggesting that we need another variable which would represent the amount I'm taking from supplier I. Do I need that? You don't need that. You can immediately write a constraint representing that value. But I need something else. What do I need? Yes? Exactly. Now, if you don't pay a fixed cost, this was okay. But now there is a fixed cost. If I decide to use this guy, I need to pay for it. And it doesn't depend on the amount. So I need a yi, 10, if warehouse I is used, and 0 otherwise. Yeah? And you need to define another variable which will help you to model the fixed cost. There is a fixed cost. Right? So our variables are, I don't have enough space here, so I won't write it full, but I have an xij, and I have a yi binary. An xij positive, representing from I to j amount. All right? Okay. Constraints. What is my constraints? What is my performance measure? What do you have in here? What can you do with this data? Give me the objective function. Give me the objective function. What can I do? I only have cost. Yeah? With this given setting, all right, there is your clients that require something, demand. There is your warehouses that can supply, and there is a cost for you. Per unit transportation cost and the fixed cost. How would you write your objective function? Let me start. Minimize what? Cost. Write me the cost. Come on, come to class, yes?
Total of I for 1 to n, plus total of C, I, J times Di.
Now, Fi is there, all right, but you're saying that Cij is here? Yes, there is a cost, but... All right, hold on. Now, when do I get this cost? You have to write the model when the cost is actually active, yeah? So this is a parameter, some Fi, sum of Fis, 100 plus, 200 plus, 500. It has to be coupled with a decision. When am I getting this cost? Only when I'm using that facility. So if I'm not using that facility, I shouldn't have this cost. This is my fixed cost, nothing to do with my transportation, right? I should only incur this cost if I make the arrangement, contract, if I buy the thingy, yeah? How can I represent it in here? Yes? Times yi. If you do this, now this is your fixed cost. If yi is 0, you don't get anything. If yi is 1, you get the cost, whatever it is. Of course, you have to tell the model when yi should be 1 and when not. You have to relate in the constraints. But this is your objective function, yeah? What else do I have in the objective function? This is my fixed cost. There's another cost, Cij. How do we write Cij? Yeah, you, because you haven't talked.
Sum of all Cij times Xij.
This time I have a double sum, Cij, Xij. All right, correct. Subject to. Okay. Okay. What are my constraints? Because if nothing, then my y's and x's are 0. Yeah? I give this to solver if there is no constraint. Minimize cost, my objective function value is 0. What do you need? What do you need? I need to see new faces raising their hands. Yeah, let me start with you.
We could start by defining that the capacity of production that we do is positive. So we could say that Xi has to be greater than AI.
You're saying what? Say it again in the mathematical terms, please.
Xi is greater, like it has to be greater than or equal to AI.
I don't have an xi. I have xij's or yi's. Xij is the amount I'm sending. He's trying to write the capacity constraint. The thing I'm sending from facility I, so there's a facility I in here, and here are my customers, yeah? So this customer J should get enough amount sent to it, and this customer, this warehouse I, shouldn't be sending more than, there's an AI in here, and there's a DJ in here. How about we write these constraints? He started with the capacity. Shall we write the capacity first? Let's do that. Would you try to do it again? Because what you said was not correct enough.
Then we would write Xij has to be greater than or equal to AIJ.
I don't have an AIJ. Is this what you're saying? Is he correct? What is this? I'm multiplying the capacity of my warehouse and the demand of my customer, and I'm sending the whole total? I don't think this makes much sense, does it? Class, do you agree with him? Who agrees with him? Who does not? Let me see the hands. Great, you're with me. Okay, let's write it again. Try again. Write me the capacity constraint, another version. Newer faces, please. Come, or I'll ask like this. I'll pinpoint. Okay, next time I'll pinpoint. How about Oktay, you say this?
Xij is smaller and equal than AI times y.
Whoa. Do we need anything else? Is this enough? Sum of xij's over what? There are two indices for x's. What am I summing it over? I or j? Are we summing it over I or j? Come on. Who says I? Let me see the hands. If you sum it over I, and you have another I in here, how are you going to write it? If we sum it over j, and we write this for every I, this actually takes care. You fix one I, okay, warehouse 1, and you look whom you're sending to, x1, j1, 1, 1, 2, 1, 3, 1, 4. Their sum cannot be more than my capacity. And thank you for this y in here, right? Did everybody get why it is here? This is, you didn't, right? Normally, I was expecting this. I was expecting this. Yeah? Which is correct. This is the capacity constraint you used to know from the power plant example. Anything I'm sending out from I shouldn't be more than my capacity. Let's leave it like this, but what he said was correct, so we're going to do it in a minute. How about we write the demand constraint? The customer, you have to send that much amount. So this takes care of this part of the journey, supplier side. Now, tell me the constraint for the demand side. Because if you solve this, your x's are, again, 0. If you optimize this, they all come with a cost, so nothing is sent, right? Satisfy the demand. I'm going to pinpoint. Come on. Satisfy the demand. How would you do that? How would you make sure that there is enough amount of flow sent to customer J? Who wants to try? I'm not doing anything, just try. Don't be shy. Yeah. Exactly. Make sure that I'm sending enough flow to customer J. Yeah? And I have to tell the model that xij's are non-negative and my yi is 0, 1. Now, without the correction, now this is what I was expecting for you guys to come up with. Now I'm challenging, like we did yesterday. Now, I solve this, okay, but then my y's will be 0. Yeah? If you solve this, yeah, I'm satisfying my capacity, I'm satisfying my demand. But then, there is nothing that would make sure that if I don't pay the contract, don't send anything from there. I can't get anything from there. I have to tell the model that if yi is 0, all the x's with that I should be 0. Yeah? Remember? The project selection thingies. Not everything is binary, but this time, if there is no warehouse, if I didn't pay for it, then I cannot use it. So if yi is 0, I have to have xij's 0 for all j. Yeah? It looks like an if-then type of statement, but first of all, these are not binary. And second of all, it's a lot easier to handle this than the if-thens that I discussed. All I have to do is, if yi is 0, don't send anything. If yi is 1, I can. The model will choose. Now let's remember how he fixed this. He said, write yi in here. Will it work? Why is it working? Let's convince ourselves, why is this why is this thing working? How do I convince myself in the previous cases? I was putting y equals to 0 and y equals to 1, right? Now, if y equals to 0, what happens? Yes? All such xij's become 0. If y equals to 0, this constraint all goes down to xij's less than or equal to 0. That's what I want. If I'm not paying for it, I cannot be using it, right? And if I'm not paying for it, then yi is 0. If yi is 0, every such x, every x using that index I, goes to 0. If yi is 1, I may or may not use it. I don't know. It depends on the overall cost. But I have to make sure that if yi is 0, all such x's should be 0. Yes? Clear? This is how we model fixed cost. Is it clear? If you have any questions, you have to ask. Otherwise, I'm going to another problem. Yes? I was going in which? M. And J is over N. Yeah, thank you. Any other thing? Yes?
And should we also write xij is integer?
No, because I define it as amount. It was like electricity. If it is integer, you have to, but I was using the example with electricity, so it's amount. Any other questions? A new problem then. This is an interesting problem. I really like this. Every example is a different challenge. Now we are in a different domain. We're in public domain. You are governor of a city and you want to locate hospitals. Interesting, right? What would be your performance measure when you're locating hospitals? You want to minimize what? Is there a profit? Probably not, right? So you want to be fair, equal, reach everyone. Interesting definitions of performance measures, right? So a very commonly used one in the literature is what we call covering problem. So in this setting, then, like for this municipality, it's not town, but like districts, okay? You have 5 districts, and you have 4 potential locations. You want to open minimum number of hospitals. They all come with a huge cost, right? Fixed cost, operational cost, a lot of things. So if possible, make it 1. But then, what happens if you get an emergency call and you cannot reach your customer? Well, it's not a customer, but if you're a victim, if you can't reach the patient in time, then you're going to lose lives, right? So in these types of settings, covering is a very commonly used criteria. What it is, it says, okay, open minimum number of facilities, but make sure that each district is within 10 minutes travel time from one of my hospitals. So for each district, there should be at least 1 hospital within 10 minutes drive time. This is set covering problem. So what is the performance measure? 102. What is the performance measure? Is it? Is it? What is the performance measure? Think about it. What are you trying to do? Number of hospitals. Performance measure is actually the metric that we're using in making the decision. The time issue is my environment, my service level. I want to open minimum number of hospitals so that everybody has a hospital within 10 minutes drive time. Got it? Define the variables. If you understood the question, now we are ready to define the variables. Let me rephrase. I have 5 districts, like customers, and I have 4 potential locations. I may or may not, like if I open a hospital in location 4, the district 1 is 12 minutes away. District 2 is 17 minutes away. District 3 is 7, 4 is 9, 5 is 10. So if I open a facility, hospital, in location 4, District 1 and 2 cannot make it, but I'm okay with these 3 districts. Did you get the data? Yeah, you have a question? Good, a new face, okay.
So it's I, 1, 2, 4. It is 1 if we open the hospital. And
if we open a hospital at I and 0 otherwise. Yes? This is our variable. Okay. Tell me the objective function. Minimize hospitals, okay, but tell me in mathematics. What is the objective function with this variable definition? What is the objective function? Yes. Minimize I from 1 to 4 xi. Because x1 means I have a facility at 1, x2 means I have a facility at 2. Their sum gives me my number of facilities. Okay, what are my constraints? What type of a constraint should I have to write? Time constraint. How is it going to be? Now, I have to be careful what I say. Nearest hospital should not be more than 10 minutes. Rephrase it. For every district, for every town, there have to be a facility, a hospital, within 10 minutes drive time. If I satisfy that, I'm done, yeah? So how about we look at town 1 and try to write a constraint so that town 1 is covered. Got it? I have to make sure that town 1 has a hospital within 10 minutes drive time. How do I do that? Yes?
You may say that xij must be small.
There is no xij. I only have xi.
If we say j and it's the travel time maybe to the potential location.
It is there, 10, 15, 8, 12. Utilize the table. You're in the correct track, but don't make it over challenging. It's a lot easier. First of all, you don't need the second index. Try again. Look at town 1. Let's write it together, as if we're in the practice session. Look at town 1. Now, what do I have to do so that there is a facility within 10 minutes for town 1? What, we have to locate 1 or 3. That's it. So in order to cover town 1, I have to have a facility at 1 or 3, right? So what is it? I have to have a facility, at least one facility at 1 or 3. How do we write this? How do we write this? It's dead easy, yes? You write this. This makes sure that town 1 has a hospital within 10 minutes drive time. Right? Clear? How about town 2? What do I need for town 2? Look at the column of town 2. Whom do I need? Which facilities do I need? X2 plus X3 should be at least 1 so that town 2 has a facility nearby. Yeah? Town 3. Town 4. X1 plus X4 and X3 plus X4. Yes? Got it? Yes?
What would have been a different solution if you had to find a second variable, which is distance?
Is distance a variable? He's suggesting to define another variable representing the distance between hospital I and client J. Is that a variable or a parameter? It's here. It's a parameter, I know it. Right? We will come to that sometime. Now, this is an interesting situation. We will have when we need that to in our X's. We will need Xij's, but not now. Any other questions? You see how challenging we're going to? And then all of a sudden the constraints are really easy, yeah? Once you get it, once you get the hint of it, it's easy. Any questions? This is called set covering problem in the literature. You want to make sure that everybody is covered, and in our case, covered is there's a facility within 10 minutes. In our environment, it's like that. Everybody is covered, and we're making with the minimum number of facilities. Open minimum number of facilities so that everybody is covered. Within the coverage definition, in our case, our coverage definition was having a facility within 10 minutes time. What you end up with is the set covering problem. Yes? Huh? How do we do this? We will learn it in a minute. Pretty much in a minute. Do I give you the general? It has a general form, but I'm not teaching it. All right, I'll do that. Or maybe we'll discuss in the practice sessions next week. Probably. But it is doable. Because we play with it and we let the Java do the rest. All right. Yes. Do we have one variable in here? Yeah. We have m variables if m represents my number of potential sites. For each potential site, you define a binary variable saying if there is a hospital there or not, hospital there or not, hospital there or not. Because the problem doesn't care who goes to where. That's the thing that makes you not understand it. I don't care who goes to where as the municipality. All I want is everybody has a facility within 10 minutes. Now, for customer one, I'm making sure that there's a hospital within 10 minutes. Whom does it go? I don't know, and I don't care. For the sake of this problem, we don't care. That's why we don't define Xij if I goes to J. I don't care, right? Now, these binary variables, yes, they help us a lot in representing real life, but they are a lot more challenging in solving them, all right? So if you don't have to, we don't define them. That's very crucial. Clear? All right. Now, there's a huge literature on location problems. You may remember my discussions from 102 in this logistics or in the humanitarian thingy. We were always locating something, right? There's a huge literature, and it happens a lot. It appears a lot. You can convert many different problems to location problems too. So we're going to see the three. And remember, when we were making all these possibilities, I was telling you, once you learn 202, you will be done with those combinations, and the mathematical model will take care of it. Now we're going to learn how to model them, all right? So there are three versions. Cover, center, median. Cover is the one that we just did, the hospital thingy. It was set covering version. Now we have another example. We have another example. This time, we're locating fires. Oh, this is the data for all the three problems that we're going to solve, all right? Let's read the problem A first. Okay, Ankara municipality, 6 districts. And we're going to locate fire stations. It says minimum number of fire stations so that every district is covered within 15 minutes. So what is this similar to? We just did the hospital thingy. Make sure that everybody is having someone within 15 and open minimum number of fire stations. All right, what was the decision variable? Let me bring back the data. Here's my data. Each district this time, now in the previous case, hospitals, potential locations, and my customers were 2 different sets. In real life, what we usually do is we set a district and we put the thingy in the district too, right? So that's what's happening in here. Ankara is divided into 6 districts, and each district is actually a potential location for my fire station. I want to minimize. So what is my decision variable? How many decision variables do I have? How many? How many? 6. What is the variable? What is the variable? If there exists a fire station at I and 0 otherwise, right? What is the objective function? Minimize summation of xi. I goes from 1 to 6. And my constraints? It says 15 minutes. What do I do in the first one? What is the constraint for region 1? Come on.
X1 plus X2 smaller or greater or equal to 1.
Exactly. This is region 1. Region 2. Right? And you write it like this. I'm not going to finish it, but you do it on your own. Let's do the general version. You guys are also want to know it, right? Okay. Are you all with me up until now? I'm going to open a parenthesis and teach something which is not in the notes. Okay. Now, this is my distance data, right? And this is a parameter, as we just discussed a couple of minutes ago. What I'm going to do now is I will define a new parameter. Be careful. It's still a parameter. I will say aij 10. But be careful. It is a parameter. If tij less than or equal to 15, 0 otherwise. It's not a variable. I'm just converting this T matrix to an A matrix with 0s and 1s only. Yeah? And this A matrix now will represent who covers whom. The thing I promised to a question coming from you guys, actually, right? Okay. This will tell me who covers whom. It's already there. It's not my decision. It's data. It's my environment still. All right? Now, how would you write the constraint for regions then? I will have a greater than or equal to 1, and I will have my region, let's say, J. Whom are you summing over? Yes?
Aij multiplied with xi.
That's it, or do you... Summation is over what? Which index? I. This is it. Let's see. First of all, this is not nonlinear. I'm not multiplying two variables. This is still a parameter, all right? So it's, even though I define it, I'm just rephrasing my data. It's the data given to me. I just recalculate, pre-process my data, because I don't care how many minutes it actually takes. I only care if it is less than 15 or not. So I convert this matrix to a 0-1 matrix. It is still data, okay? Now I'm here. I'm taking my index J, my customer J. And what is this summing over? I'm looking at the, taking the xi's for which the AI is 1. Did you get it? This is a very, 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 very nice trick. I love it. You don't get it? Did you get it or not? You get it, good. Yes? You didn't get it. Okay. Let's look. The suggestion was sum over I, ai j xj should be at least 1, no, xi for all j. I'm going to write it in the open form, then you will see what it happens for all j. This constraint says pick one j for all j. So I pick j, let j equals to 1. What does this says? It says ai1x1 plus, so a11x1, a21x2 plus a31x3, a41x4, a51x5, a61x6, a61x6 should be at least 1. This is what it says. Okay, let's look what these a's are. a11. a11 is 1 if the distance is less than 15, so it's a 1. So it's going to say x1 plus a21 from 2 to 1. It's another 1, so it's going to say x2 plus a31, no. a41, no. 51, no. 61, no. Greater than equal to 1. You got it? So when you open it, so this version, where is it gone? I don't know, where is it? Whatever. So the one on top, this version, is actually helping us to write a compact formulation. That's what we call the compact formulation. If you don't want to do it for all the regions, you can write it like this. It's still correct. That's how you're supposed to do if you're solving it in a solver anyway, Excel, Express, GAMS, Cplex. That's what you're supposed to do. You're not going to write it one by one. You're going to have a code to do it for yourself. So this is the coded version. Yes?
We write the 0, 1 matrix to the model, but how can we teach the table to the model?
You write you do an Excel, JavaScript for yourself to convert this T. So you have the T, yeah? Tij matrix. This is the Tij matrix. You convert that to your A matrix. It's a pre-process. You do it on your own. Then the mathematical model utilizes this only. Got it? That's what you're doing in your mind anyway when you're writing the constraints. One by one. You're looking, less than 15, so that counts. Less than 15, that counts. So what we do is do it before, make it a matrix, so that you can let Python do it for you. Clear? Questions? All right, we will finish these location models on Monday. And I repeat, your next homework will be available today. Yes? Huh?